Welcome to the new part of AI 0 to 1 series. In this part, we will be setting up vector databases. Vector databases is one of the key ingredients or components that help us composing AI applications. There are many open source and proprietary vector databases available, and we can utilize them while creating applications. Some of these vector databases are open source and we can pull in their containers on our local machine. And some of them are actually hosted in cloud and they are proprietary, but they offer free tier that we can use while experimenting or developing applications. Postgres database also offer vector store. Similarly, we have Superbase that is based on Postgres and they have online offering that we have already used. They also have vector support. Then we have Milvus, Weaviate, Qdrant. We can use Redis as a vector database as well. And then we have Pinecone, which is proprietary and it is not open source. Let's talk about embeddings or vector embeddings, where we convert text or words into numbers before we can store them into our vector database. Here we have text and we can convert it into numbers. Here we have the number representation of words. After that, we store them into vector database. Then we can retrieve them to use with LLM or for any other purpose. Let's have a look at some use cases of vector databases in AI. And the top one is RAG, Retrieval Augmented Generation, where we can chat with our own documents, images, and videos. Then we have AI agents, and this is talk of the town these days. They will be able to perform different tasks on behalf of the users. And then we have similarity, where we can find a similar images, sounds, videos for recommendation systems or any other purpose. Then we have anomaly detection, where we can use vector databases. In anomaly detection, the example could be like security and intrusion detection. Then we have clustering and classification and geospatial applications. We use Superbase in our earlier examples, especially in TypeScript series. Superbase also provide us a solution to vector embeddings. And we can store real-time data streams, and here we have the vectors. The section here, it provides different starters that we might be interested in, like AI chatbots. We have LangChain plus Next.js starter, and different vector databases have different advantages in terms of their scalability, performance, and their capacity of handling multidimensional data. And some of them are open source and some of them are closed sourced. So it depends upon nature of your project, size of your project, and project demands that will allow you to select a particular database for your project. To go through this Qdrant or Quadrant, powering the next generation of API applications with advanced open source vectors, similarity search technology, and their offerings are appearing here. So if you sign in, you can get the cloud offering. They have a free tier and with a zero point 0.5 CPU, 1 GB RAM, and 4 GB disk, and one node. Let's create a cluster with one node here. Test cluster allow you to create or generate API key. The cluster creation will take some time. One interesting thing is that it is open source and we can pull in Docker container and run Qdrant on our own machine for storing vectors. So, so they want me to store it somewhere. Go to access database. I can provide the API key here. Observe the port number and the URL. You can use this URL to access your database from your application. Here is the quadrant or Qdrant documentation, and it also tells us that how we can install Qdrant on our local machine. It provides API and SDK documentation as well for different languages. Have a look at here. We have Python, TypeScript, Rust, Go, .NET, and Java SDKs available. And apart from that, we have REST API and gRPC API. That is one of the binary protocols that we use with microservices. And we have REST API available here. It is totally your choice to use the cloud offering or to install it on your own machine. So I'll be actually installing it on my own machine using Dockers. I'm on Docker's Hub. Let's search Qdrant. And here we have Qdrant. So I'm copying this from here. I assume that you have already installed Dockers on your local machine or Docker UI. So let's pull it, the latest version. And I've already pulled this, so I'll not be pulling it again. You can also use Docker's UI to pull in Qdrant on your own machine and then run it. I've already written Docker compose file here, which is pretty simple, and we have explored this many times in our TypeScript series. So it's pretty straightforward, showing the services, and I have the Qdrant service defining the image, which I'll not be pulling because I've already pulled. And then I'm mapping the ports to internal and external ports, the local machine port to the inside image port, and then I have the storage that I'm mapping here to one of my local directories. I run the Docker Compose up. It will be starting the container, and if I go to Docker desktop, here I can see I have a running container here with quadrant-1 name. And if we go to the documentation here and click open API specification, we can call different endpoints either using Postman. I can create collections using this endpoint with the port, either using curl or using the Postman. Endpoints related to Prometheus and other telemetry data, indices, search, points for adding, removing vectors. I've already created few endpoints here in my Postman, and we have used Postman a lot in our previous series. Here I have localhost 6333 and I have a get verb here, and let's see what it returns. And I'm getting 200 OK. Qdrant vector search engine and the version. Let's try to create a new collection to store vectors, and for that purpose we have localhost 6333 slash collection slash test3. That is the name of the collection I want to create. Maybe I can change it, maybe 7. So if we come to this particular part here, we have size. The size is dimensionality of the vectors, and in this case it is 768, which is quite common for BERT. We will discuss that later in some other video. We have the distance. Distance matrices are used to measure similarity between the vectors, and here we have cosine distance. Let's try creating one. So I get back the true OK status on my local machine, and I have my test 7 collection ready to store vectors that I will generate using embeddings. Pinecone is an other alternative vector database. It is a proprietary database, but they have free tier. And if we go here, we can see that we can start for free, serverless, 2 GB storage included, and there are fixed number of write and read units per month. So signing in will give me the access, and here I am. It allows me to connect to this database using different languages, just like the one we have explored before. We can generate API keys, and if we go and here it's showing some sample code. Choose a hosting model. This is for embedding. Go to model gallery as well. Here are the rates for producing embedding. This one is for re-ranking, and Pinecone Spare English V0 is for embedding. Milvus, and it is also open source, and they claim that they perform high-speed searches and scale to tens of billions of vectors with minimal performance loss, built for Gen AI applications. I can pull Milvus from Docker's Hub from this page, copy the command docker pull. Weaviate is an alternative option for us to serve as a vector database, and it has a free cloud offering as well. It is limited. We can also pull it as a Docker container on our local machine. Then we have option of Redis, which we have already used in other episodes, and we can use it as in-memory vector database store. It was a brief introduction to vector databases, and in next episode we will be using Qdrant and maybe Redis to develop a RAG application. So stay tuned.